to the Berlin Functional Programming Group. I am really excited tonight to introduce to you a very close friend of mine, and I'm so excited to introduce him. I dare say I am emotional. Chris Allen is going to be unusually embarrassed, I would say, by my introduction, which I have not rehearsed. I thought long and hard about what I wanted to say, and it's been a struggle. I really have to flex my my MC muscles tonight, because I truly and without exaggeration would not be here doing this. I would not be here doing what I'm doing in my career if it were not for Chris and his guidance and his efforts on my behalf. In 2016, I discovered the Haskell programming language, and it wasn't very long before I discovered the book that he co-authored, Haskell Programming from First Principles. And I don't know how it happened. I discovered the FP Chat Slack group and the Haskell Beginners channel, which Chris also founded and has for a long time kept a watchful eye on. I've learned this about Chris. He sees everything that happens, and he really cares about beginners, and he wants to make sure they're given an appropriate introduction to Haskell, because he really cares about this language and the community, and he doesn't want to see anybody turned off, turned away, driven away. He wants people to feel empowered by Haskell, not intimidated by Haskell. And I developed a very casual acquaintanceship with him, I would say. And at some point I casually mentioned I would be interested in attending a functional programming conference, LambdaConf, that year. I think it was 2016, casually mentioned, but I was a graduate student, rich in spirit, but poor in finances. And there's no way at that time I could have afforded to go to a tech conference. And I mentioned this. I actually mentioned this to no one in particular. I didn't mention it to Chris, but because Chris sees everything, because he is a living, breathing, functional programming panopticon, he noticed this and he said, there's no way on my watch someone who wants to go to this conference and who in his mind, I don't know why, deserves to go to this conference will not go if I can do anything about it. Fortunately, he and his co-author were sponsoring the conference that year due to the book, and he invited me to go to the conference. Not only did he get me a ticket to the conference, he paid for my airfare from New York, where I was living at the time, to Colorado, where the conference was held. And he introduced me to people. He brought me into this community, and he continued the relationship. This was before we had become friends. He offered assistance and guidance with the book and the exercises in it, with the community itself, with learning how to become a programmer. At that time, I was a graduate student in English literature, kind of looking starry-eyed at the software development field. And whatever cynicism I may have developed in the meantime, it's still a privilege to be in this field, to work in this industry, and very difficult to break into it. And I really do not believe this would have been possible without Chris's help, advice, support. The following year, we traveled to LambdaConf together. I flew to Austin and we drove together through New Mexico. Beautiful, beautiful. Remember, Chris? Beautiful drive all the way to Boulder.
I remember the rosary I bought at the cathedral too.
Yeah, I think I remember that. I don't know if that was the first time or the second time, because we did this 2 years in a row. The third time I went to LambdaConf, we all rented a house together, a large group of us, and I had a blast. But the important thing here is Chris has done so much for this community, and I know that some people can sometimes find him prickly, but he has the biggest heart of any software developer I have ever met, and quite large among all the humans I have ever met. I am privileged to have met him and to have benefited from his generosity, as so many have benefited from his generosity. I don't think I would be in this career. I don't think this meetup would exist. I don't think we would be here today if it weren't for him. I just want to publicly be able to take the opportunity to thank him for all of that, and maybe even apologize to him for not being in touch as much recently as in the past. He understands himself acutely now, being a family man himself, that it can be hard to find the time, especially since I've moved away to a foreign country and started a full-time job, largely thanks to him, and have progressed in my career in no small part thanks to him. That unfortunately it's been tough to maintain ongoing relationships, but I have not forgotten him. His generosity continues to act in my life, and I continue to think of him, and I'm glad to call him my friend and proud to host him this evening in our meetup. And I know that you don't want to hear me go on like this for any longer, so I'm going to hand it over to Chris. I haven't really given him much of a biographical introduction. He is one of the co-authors of Haskell Programming from First Principles. He is my friend, he is a talented developer, and he's going to tell you tonight how to be an effective liar in Haskell. Chris Allen.
Wow. Thank you. Yeah, no, Steve's definitely one of the funniest and most interesting people I've met. I mean, from my point of view, I just directed some funding and made a friend. He's done all the work. He learned everything he's done and made is him, not me. So a little bit about my background, because I think some of you may have seen my LambdaConf talks, but may not really know where I came from or anything. I'm a working developer. I've worked in the industry since the fall of 2008, so almost 12 years this fall. Started out in Python, then did Clojure, got disenchanted with the lack of types, and I used enough programming languages in the back of my head. I kind of knew that, there was a better way. It didn't have to be like this, And, but I wasn't willing to give up, software transactional memory, nice concurrency toolkit. Well, that kind of narrowed it down, and it basically meant Haskell or nothing. So I kind of had an Odysseus burns the ships moment and said that, this is like attempt number 3 or 4 of me trying to learn Haskell. I started trying to learn it in 2007 or 8, and I kept failing to learn it. I couldn't get traction with it, And I did succeed that time, possibly out of desperation, possibly by just being really annoying in IRC. And I don't know, it just seemed to me like it didn't have to be that hard. And that's what led to me figuring out how to teach Haskell, because I can't use it unless my coworkers can use it, and that means I need to be able to teach them. And then I realized I could kind of scale it up by just condensing what I learned into a book. So let me share my screen and we will start talking. So by the way, he's not kidding about the prickly part. I'm kind of a grumpy bear. I apologize. But I do actually really like people. And if, you want to ask me a question, if I can help with something, whatever, here's my public contact info, cma@bitmap.com, career advice, question about the book, whatever. The book actually has like a separate support channel. You can use that. I don't care. Do what you want. But if you want to direct somebody to the book, you can just send them to haskellbook.com. It will just take them to LorePub now, because I finally got rid of Gumroad, and now it's my own website that I wrote in, drumroll, Haskell, right? I'm working on print. I'm basically working on back office software to manage and track fulfillment. Once that's done, I will probably do a pre-sale to fund the print run and also to estimate volume. The estimation of volume is really the big thing, because I need to know how many books I need to print to meet demand. So pre-sale is the easiest way to do that. No date on that yet.
The spelling, grammar, and punctuation in this book are perfect, by the way.
Yeah. So the editor for the book was Steve, and he is terrifyingly thorough. That is both a compliment and a warning. He did a fantastic job though, and I don't know if I'll be able to, but I would like to Tom Sawyer him into editing another book. We'll see. So yeah, let me know if you have any questions. Other than that, I'll move on to the topic of the day. So I titled this talk, How to Be an Effective Liar in Haskell, and I have to admit this topic was triggered in part by, well, me getting a little bit triggered on Twitter because I saw people that don't really use typed languages, and especially Haskell on a regular basis, talk about how, oh, I can't use a typed language because I have to get everything right all at once, and that's not practical. And I need to be able to kind of isolate the part of the problem I'm working on. Well, great news. You can do that in Haskell just fine. So basically, we're going to talk about how to do a little bit of type quando, you could call it, how to shadow box with the type checker, how to kind of defer and shift around like what part of the problem you're trying to chew on, that kind of thing. There are no slides for this. It's just code and demo. The exercises are by and large from the book. So if you've already done the book, I apologize. These exercises will be familiar to you. However, the way I go about solving them might be novel and useful to you. So that's my hope here, is that I can at least do something new, or at least slightly different enough that you learn something. I'm going to touch on scope type variables and pre-next form a little bit real quick, because that will become relevant later. And I'll talk a little bit about how I generally work in Haskell. First, real quick, I'm adjusting font sizes here. Is this good? Does everybody find this legible? Got one yes. 2 yeses, 3. Okay, I'm gonna call this good. Okay, so I'm gonna go ahead and load this module and talk about what's going on here. So pretty much anybody who's used Haskell for any amount of time has seen a type error like this before. Couldn't match expected type B1 with actual type B. Okay, so some of you, probably most of you actually, already know what's going on here. So the problem is that we tried to ascribe this type to f of x. We get rid of the type description and problem goes away. Okay, well, what's the problem? The problem is that you are instantiating a new b when you do that type description. It's a new variable. It's not the same one that's up here, right? So what's happening in practice is you have 2 for alls here. Actually, whoops, I did that wrong. It has to go after the double. There you go. Okay, so that makes the situation a little more obvious. So basically, the way type signatures work by default in Haskell, assuming you don't have other language pragmas or other things in play, is that it just auto for alls all the variables you introduced for you, right? And if you're familiar with the lambda cube, this is actually like the type level lambda calculus. The for all is like introducing a variable at the head of a lambda. It's the same idea, and the scoping rules work basically the same way. It's just less direct than just working with normal term level lambdas. So yeah, the issue is that this b is not equal to this b any more than this x would be equal to that x. It shadowed the outer x, right? So same idea. The reason this comes up is that the reason I'm covering this is because when you start learning how to isolate and work with sub-expressions and differ which parts you do and do not care about, you're going to basically run into needing this. Because a lot of the time you're going to need it just because you're working with polymorphic types anyway. So you're going to want to understand this. Well, okay, how do we do it so that there is no pre-next form here and it just works? Well, the answer is scope type variables. So if you just do for all b, whoops, gotta introduce the b there, and there we go. Okay, so now a and b are scoped to this entire function body. So you can do like a equals x, f of a, that works fine, because a and b are no longer, there's not an implicit for all, like introducing a new a here. It's just reusing the a from the outer scope. Okay, before I move on, any questions about that? That was a lot all at once. I once did an entire conference talk on this, and I just condensed it to like 5 or 10 minutes. Okay, I don't see questions. So let's go to, let's see here. Let's do transformers. So I have two pragmas in here. One's instance SIGs and one's scope type variables. Okay. So let me load transformers. All right. So this type checks right now, and it type checks because all the stuff I didn't implement is set to undefined, right? And if you've worked through the book, you've seen us use undefined in there a fair bit. I want to talk about how to use error and undefined, because undefined is just it's just error with, you know, some default text basically. Let me actually ask this real quick. Is there anyone in the audience that isn't comfortable with undefined or error or bottom in general? I'd like to know if I should cover that in any depth, just in case like somebody who watches the, okay, yeah, please cover that. Okay, so I'm not going to get into the type theoretic issues of bottom, but basically undefined is justified on the basis that we can have an infinite loop, something that doesn't terminate or, you know, reduce to like some normal form or whatever. So because that's a possibility, the concept of just something that doesn't evaluate, doesn't return a value, doesn't reduce to a value, undefined is kind of the reification of that idea. And they don't function the same as IO exceptions, and you should not use them in place of either exceptions or an explicit, you know, value that signals some other possibility like either, right? Because it's really like the two main ways you do error handling is either or exceptions, and then exceptions breaks down into synchronous and asynchronous exceptions. So this isn't for that. Undefined is really for active development. It's so that you can say, you know, I don't know how to do this yet. I don't want to implement this yet. Let me just kind of, you know, put a stake in this, leave it for a second while I do something else, that kind of thing. So for example, you could use it to, for the sake of argument, let's say you have some function and it has the type, we'll say it parses numbers out of strings of a particular format, right? Okay, but you're not really interested in implementing that right now. You just want to posit that such a function exists and get on with the rest of what you're trying to do, right? So that's a good use case for undefined. But your final version of whatever it is you're making, like the thing that you would actually post as like a non-work in progress merge request, shouldn't have any of these in there. And there are some cases when you're doing something really, really, really tricky. I'm thinking of some of the applicative instances for containers that I can't remember his name right now. I apologize, but he was working on some performance for the applicative instances, and I was talking to him about it. And some of the cases were in the pattern match basically weren't supposed to really ever happen, but there also wasn't like a sensible result if they did happen. So he had just, you know, error or undefined in there, and I asked him to try to figure out how to purge those and redesign the code so that that didn't happen. And the thing is like when you're doing like high performance code or something tricky, you might have some impossible cases that you have to account for in your function that, you know, just return like error or something. But in normal business code, there's really no reason. You can return maybe, you can return really better either. If it's truly exceptional and can't really be dealt with in a normal way or kind of dispensed with or discharged in a normal way, then a synchronous exception could make sense. Yeah, so we use undefined a lot in the in some of the chapters around lists and especially folds and figuring out when you evaluate something. That's another good use for undefined. So because if you force, I'll give you an example, quick little example here. So if you have 1 plus undefined, it blows up. You can actually use error to figure out which argument it forces first. It forced the right-hand side first. And then if you wanted to get really clever, you could start ascribing different types to see if that changed which one it forced first. So if the num instance is int, float, or double, it forces the left-hand argument first. If it's an integer, it forces the right-hand argument first. I bet you never thought about that before, huh? So error and undefined are pretty useful for figuring out what order things get forced in, stuff like that. They're good kind of evaluation canaries, is one way you can think about it. But again, this is for like interactive development, you know, figuring things out and that sort of deal. And then the way you work with something like this, you know, the stubbed out function is usually in the context of writing something larger and then seeing what would happen, right? So you could have parse and add, and then you have two strings and maybe and S1, S2, and then you can have let parsed 1. So this is another thing about the way I work in Haskell. I generally, I use a text editor side by side with a GHC terminal. Usually I just use stack GHC or some equivalent for the project. This has been the most productive because trying to write non-trivial code in the REPL usually isn't productive, but there isn't really like there isn't what I would call like a good IDE for Haskell yet. There are some things that are creeping a little bit closer, but they aren't reliable enough, especially on larger projects, for me to really use them. So I mostly just use the REPL. And so there are a few things we can do here. So one is, we know we're going to return maybe in eventually, but I can actually just return undefined, and there we go. I don't have to deal with the fact that I'm supposed to eventually return a result of this type. And these parts type checked. Well, fair enough. Undefined lets you say you returned any type you want, including impossible types like void, right? So let's go ahead and ascribe a type to these and see if things are as we expect. Okay, that compiled. What if I say unit? Okay, so we just got a useful type error telling us we made a mistake, our assumptions are wrong, about code that doesn't even really exist, right? Transmogrifier doesn't exist, the string doesn't exist, we haven't really done any real work here, but you know, you can use unit, some people use string, just pick some concrete type that it's definitely not going to be, and you can basically set the expression up for contradiction. You're basically intentionally contradicting the type checker to force the type checker to tell you, okay, well, it's definitely not this, so I'm going to assert that it's this, just so you tell me what it actually is. And it did. It told me it was actually a maybe int. All right, let's see here. It's exponad. I use exponad. It's actually been misbehaving a little bit lately, a little concerning. But yeah, the exponad's been my preferred window manager for some time now. Okay, so that worked. And then you know, if you want to kind of tease this out and you know get even maybe a little more tortured about it, you can start breaking out sub-expressions and giving them names and types to see what they are. Okay, it's maybe int, right? And the fact that the maybe type constructor is wrapped around the partially applied function is why we need applicative for the second application, right? So if I change this to maybe int, it works again. And you know, there's not a lot more to break down there. That's basically it. And then you can do things like, so if we try to actually pass results to this, it's going to blow up on the undefined from transmogrifier, right? But you could also just, you know, instead of actually evaluating it, you could just ask it for the type and then see that it's maybe int, right? And then you can test more expressions made of that and see if they would at least type check that idea, right? So we've posited this expression. We haven't actually evaluated it. We're not bothering to evaluate it. We're just saying, does this even type check? Could we do this if it actually worked correctly? And the answer is yeah, and the result would be maybe int, right? So adding together the results of two different parse and adds, basically, right? So especially when you're working on tricky code that isn't something you can just kind of bang out, you know, like stop, pause, think to yourself for a moment, and then just bang it out. Some code you run into is going to be like that, right? You're going to run into more of that when you're doing exercises or working through a book. I know the Bird book has exercises that are like much harder than what the Haskell book has. I think some of the other books have exercises. You're definitely going to run into it, and it'll happen even in normal application code. Not as often. Normal day-to-day Haskell development's actually like pretty nice and low drama, especially if you're not dealing with code made by somebody who's trying to suck air in the stratosphere. But it'll happen from time to time. You know, maybe you're changing like the way your transformer stack works in your application, or you know, you're just kind of in the guts of something a little bit tricky. And you know, especially when you're working on a larger application, you want to be able to kind of make tentative changes to the monad stack or something without having to actually do all the work just to see if what you're proposing would even type check. And that's where things like undefined and that sort of thing come in. You can actually go even further. So if you don't want to manually stub out an undefined, or maybe you made some change was made to a library that that broke your package, and you want to do something else that that isn't going to type check. So there's another strategy for that. So you can think about it as kind of small scope, big scope. So for small scope, when you kind of control the definition of something, you're just trying to stub out one little expression or declaration or something, you can use undefined or error, right? For bigger scope stuff, you're going to want something called defer type errors. And the way this works is, I think it's a little funny, actually. Let me stub out a quick function here, and I will show you how it works. So let's say we have an expression n equals s plus 1 int, and put string line hello, and we deferred type errors, reload. Okay, so here's your first hint that things are a little bit different. This is a type error inside a warning. And that's because I deferred type errors, right, with the colon set dash f. By the way, if you didn't know, you can just tab complete all the flags in GHCI. Fun fact. Okay, so let me jiggle it so it re-emits the error here. So we tried to add a string and an int. That obviously doesn't work. Okay, so what happens? Well, it worked. Okay, audience participation. Who can tell me why it worked? Let's see if any of you already know. Say so in the chat. There you go. So if I try to print n here and do it again, it blows up. So
repeat the correct answer just so.
Oh yeah, sorry.
Video
so
later, they'll know. Yeah.
I apologize. Yeah. So the correct answer is that say hello previously worked because n was not used. And the reason that's relevant is that the way deferred type errors works is every expression or declaration, anything that you could possibly use that doesn't type check, it just turns into a bottom, like an error, basically, right? And I have like a funny example here of how non-strictness in Haskell works. So obviously, like it rendered a type error as an exception, right? And this is not something you ever want in a production program. Please don't do this with an actual production program. But does anybody notice the little double quotation mark right there? Pretty cool, right? So it actually started using basically the show instance of a string, and it can emit the double quotation mark that begins with the show instance of every string before it needs to actually evaluate the value, even if the value is a bottom and there's nothing at all to be extracted from it, right? So it started rendering a string because that's what it thought the type of n was. I can make that more explicit by doing this and then doing that and doing that. Oh, it actually changed the result. Hold on. Oh. What did it think was going on? Well, I'm wrong about that, or I'm missing something. But normally when you see that, and I can show you an example here. So when you do like empty string, concatenate, undefined, you can see the quotation mark at the beginning, and then it actually renders the undefined immediately after. So that's what I thought was going on there. Looks like there might be something a little bit weirder going on. Let me try something. Okay. Yep, I am not sure what about it is making it render a double quote when there's no type ascribed, but let me try that and see what it says. Okay, so it says that it says n is a list of car. So the question is why is ascribing a type to it changing the result? Interesting question. Okay. This shouldn't change anything. It's the same instance, but just for the sake of my paranoia, yeah. Okay, I don't know. Okay, so yeah, deferred type errors will turn all of your type errors into exceptions, and specifically not IO exceptions that can occur anywhere that you should really never use. You should avoid that in a real production program. But if you need to be able to build it just for the sake of kind of running it and seeing where it trips over something first, if you only need to run like some small sliver or vertical slicing application not affected by the type error. It can help for investigating that. So I would say FDefer type errors comes up a lot less often than using undefined and error, but it does come up. Oh, let me see here. Any questions about this? Access because string doesn't need a show instance. No, it has one. Let's see if we can pull a base here. And I'll go to prelude because it's going to have it regardless. And then where's the instance listing? There it is. I think it's might be like some car or something. Good grief. Show string, show bracket. There we go. So yeah, show list, and then it specializes it for list of string, list of car, list event. Okay, well, that's a mystery for another day. Let's see here. All right, so I think next we're gonna go through some exercises and use the techniques I've demonstrated. Any quick questions before I take a quick bio break? Okay. Well, I'm going to take a quick break and then we'll start on the exercises. Okie dokie.
I told everyone that at the end of the talk, you would be perfectly happy to entertain general Haskell questions or questions about the book as well. Hope that's okay.
Yeah, that sounds good. Can you see and hear me okay? Okay, all right, so I will continue. Okay, so this one, we're gonna.
Looks like you have a question from Thales.
Oh yeah, sorry. Thales asked to use GHC ID with Emacs, HIE, something else. None of the above, really. If I want to use GHC ID, I use the actual terminal app, just to give people an idea of what I'm talking about here. GHC ID can be pretty handy because it just like very quickly reloads and shows you any type errors you might have, that kind of thing. I will use GHC ID in a terminal when I am heavily and rapidly refactoring something. And let me see here. So I actually, it's bugging out on me a little bit. Okay, there we go. The sharing bar was on even though I wasn't sharing. Can you see my screen? You can now. Okay, good. I'm glad. So yeah, so if I'm going to use GHC ID, I just use the actual like terminal application, and I will often have. So I always use Makefile as like a command palette for my projects, and pretty quickly I'll have like a make GHCI and then a make GHC ID that loads my project. I typically use GHC ID when I'm making rapid changes to a project, but it's a situation where I'm refactoring something and it's kind of compartmentalized basically, where I make a change in say one place that breaks a bunch of stuff, and then the type error output from GHC ID is basically a checklist or to-do list, and I'm just going through and fixing the things that show up in GHC ID, and then I'm just knocking them out one after another. And that's typically when I use GHC ID. I mentioned this earlier, but I don't really use any IDE type things integrated in the editor. I don't find they work very well. They fall apart on projects of non-trivial size pretty quickly. It's not their fault. The core issue is that they keep trying to use the GHC API that the compiler furnishes, and that's just never really going to be efficient enough or well suited enough to an IDE. People are just going to have to buckle down and make a parser and, you know, type checker and code analysis engine from scratch that's tuned to the needs of an IDE. That's what IntelliJ does. But it's work, so nobody wants to do it. I don't blame them. I don't want to do it either. So, but yeah, so I'll use GCID in a terminal. You probably see some squigglies in my Emacs here and there. Ignore them. I didn't ask for them. That's just Haskell mode being very forward with me. Yeah, that's my purse. I don't know you kind of thing. So I just haven't bothered to figure out how to roll back the Haskell mode version to make it go away. So, okay. We have identity, which is just a new type wrapper for some type A. It's pretty boring. But we'll break it down real quick. And this is a situation where audience participation is going to help me to kind of make this more interesting. If this is excessively basic, please speak up. If you think it's about right, let me know, that kind of thing. I want to make certain I'm using examples that are kind of tuned to people's knowledge and experience level. But yeah, so, okay, let's try x equals f of a, and I'm going to kill that and restart it to get rid of the f for type errors. I'm going to take these, drop them at the bottom, pop back up here in undefined. All right, so what we're doing here is we're just trying the first most obvious possible thing. We have an f, we have an a, let's apply f to a and see what happens, right? Okay, cannot construct the infinite type, a equal to or equivalent to identity a. Okay, well, fair enough. Okay, so what if we run identity on a first? Ah, I compiled. Okay, well, what if I try returning x? Okay, well, we get b does not equal identity b. So what if I wrap identity around that? And there you go. Edward asked, I've seen people use things like run parser for new types. Is a convention to just make it run x for the record of a new type? Not all new types. It's a good question. So there are basically two idioms, and this is actually slightly unidiomatic. More commonly, it would be unidentity rather than run identity. So the reason is because we use run and then the name of the type or whatever, usually in the context of a monad transformer, like this identity T here, or maybe T. And then you use un as just kind of the, you know, the isomorphism opposite of the data constructor for the new type. The reason for run is that usually, not always, but usually in the context of monad transformers, you invoke the deconstructor, the unpacker accessor for the new type when you're getting ready to actually like line up all of the structures and run them, like actually execute them. So in some cases you might see like run webT, run either T, run async. I don't know. I'm just making this up, but you might see something like that in like your main function when you're getting ready to run the web application, and then like you have like some web app value or something, that kind of thing. So that's my understanding where the run comes from. Probably somebody did that once in a paper, probably one of the Pearls. functional programming pearls or something, and then everybody started doing it after that. That's my guess. Okay, so identity is pretty boring, so we'll move on to identity T and amp it up a little bit, okay? So coming down here, so identity T is a little bit more interesting. Instead of A, it's F of A, and the type constructor is a little more interesting as well. So if we take the kind of identity, ooh, sassy. All right, one moment. There we go. So if you take the kind of identity, it's just star to star. And star is just kind of the default kind of lifted types. And then lifted types is basically almost all the ones you deal with on a regular basis. Almost nobody's dealing with the unlifted kind. The other kind you might run into is if you're using data kinds. Data kinds can be pretty handy, especially if you're using them with like phantom types or something, but that's not what today's talk is about. So pretend I said nothing. Anyway, identity T, it actually takes another type constructor as an argument, and then a normal concrete type, and then it returns a concrete type of the lifted kind. So, but it's still basically an identity monad transformer. It's like a less general identity is really what it is when you tease out the structure like that, because you have to have an F that can wrap around the A. It's less general. Anything that you put in identity T can go in identity, but the vice versa is not necessarily true. So to give you an idea of what I mean, you could have, okay, let's see here, identity T maybe int, and that kind checks, right? Because we're not type checking, we're kind checking. So, all right, fair enough. So if I do identity, I can just do maybe int, right? Those are the same types under the hood, right? They're packed up in a different way, but it's the same thing. But you can have an identity of int, but you can't do that with identity T. You need something in the middle, right? You need something of the kind star to star. Audience quiz. What could I stick in here that wouldn't change the representation of the value as the first argument to identity T to wrap around int? Identity. Exactly. Because the identity data type is to the algebra of types, what the identity function is to lambda calculus, right? Same thing. So because new types don't actually have a runtime representation generally, there might be an exception to that. I don't think so though. New types are unlifted. They don't create any new pointers. They don't box things up the way a normal data type can and does. This is actually the same exact runtime representation as just an int. And let me actually see. So identity T, identity 1, int. Okay, so that's an identity T of identity of int. And then unsafe coerce that and call it an int. And it works fine because it's just an int under the hood. New types aren't real. That's your new slogan. Okay, so don't do this like just because you know something's a new type though. Don't be bad. Be good. Okay, so we'll do the identity T real quick here. Similarly, we can do x equals f of a and undefined just to see what happens. We got a type error. Okay, fair enough. So we've got run identity T of a. Okay, now it's complaining about M of A, okay. Well, okay. So the F, let's take advantage of instance 6 here. I don't know if any of you have ever used instance 6 before, but they are handy. So the type of fmap in general is this. However, something a little different happening here, right? We've got identity Tm of A, identity Tm of B, and then we have an A to B. So let me just reload that. That type checks. Okay. Now, the reason the coerce will convert, so unsafe coerce doesn't actually do anything. It just lets you coerce or cast the type to literally anything you want. So there are problems with that, right? So you can do an unsafe coerce of like that, and that's wrong. There you go. Bonus points if you can guess why it's changing every time. Okay, so yeah, don't actually. Unsafe coerce is like, if you know it's just a new type, you can use it under the hood of a safer coerce class in order to take advantage of the fact that there's no actual work to be done to convert a new type to its underlying representation. But you can also just do that with the accessors. Maybe there's some performance difference there. I don't think so though. Because there's an actual data.coerce you can use, I believe. Whoops. Yeah, there it is. This is a safe one. It only lets you convert between coercible things. So this is the safe one. Use this. Edward guessed that the reason this was changing was because of pointers. I believe that is why, yes. I'm not going to try to prove conclusively that that is why after the quotation mark foible, but yes, I believe that's what's going on. A quick note about identity T here. The reason it's identity TM is that identity T is partially applied to make it kind star to star, because otherwise you can't have a functor of it. When you shove that type down in place of the F, you're replacing the F with identity TM. That's what's going on there. Okay, so writing these instances can be very clarifying and helpful, especially when you start playing with monad transformers, or at least I find it can be helpful. You can do what you want. Okay, so let's get rid of the type error for now. Okay, so X is something. Set it to unit. I'm wrong. Okay, it's M of A. And now it's complaining that A1 is an A, right? Well, we have scope type variables right there, right? So we can do for all M, A, B, reload, and now it works. Okay, so we just combine instance sigs with scope type variables to be able to check the fmap method type and ascribe a polymorphic type to an intermediate expression under the let here. Okay, so we know for a fact that X is M of A. This is true. We've made progress. Okay. The problem is we need to get to an M of B. Well, what do we know about M? Well, I kind of gave you the answer right here, but we know M is a functor, and in fact, it has to be in order for identity T to be a functor, right? Identity T of M to be a functor, I should say. So if we want M of B, we can fmap F over X. And it is upset. Let's see here. There you You have to re-add the functor m, even though it's actually in the instance declaration. I don't know why. Weird limitation. Shrug. Okay. Now it works. So we have x prime, which is m of b, and we had to lift the function over the, you know, whatever n is. We don't know. Okay. Well, what if I try to just return x prime? Okay, fair enough. So identity t, x prime, and we're done. So we broke down this into a step-by-step, you know, thing that lets us kind of talk to the type checker. It's kind of like you're going to have Edwin Brady on. I don't know if any of you ever worked with like a proof assistant, but this is basically me through violence forcing GHC to act like more like a proof assistant rather than just like a type checker for programs, right? I'm you know, writing little lemmas and sub expressions and assumptions and breaking them down piecemeal and making certain that each part connects to the next part, right? Okay, but that code's not going to pass code review, right? So what I usually do is I get it to work first with the piecemeal approach, and then I clean it up. One of my favorite folklore articles, I'm going to share this in the chat as well, is Make a Mess, Clean It Up. And this isn't really exactly the same kind of context, but basically one of the people who worked on the original Macintosh, they got really good at an arcade game. The reason was because they didn't let the easy mode of the game be easy. They let the, you know, the monsters get really messy and let the game get really hard, and then they got really good at recovering from adverse conditions. This isn't exactly the same idea, but that's what's going on in the back of my head when I say make a mess, clean it up. Just get it to work, you know, make your problems as small as possible, and then just work through it step by step. And then once you have something that works, you know, clean it up. So, okay, so how would we do that? Well, we've got run identity t, and then we've got fmap f, and let's see here, a, and then identity t, and that's one way you could write that, right? And actually, if you scroll up, you'll notice that this looks very similar, right? So let's try map identity t. And that works too. So either way. Does that make sense so far? And does anybody have any questions? Okay. So this presentation is partly inspired by the techniques I had to learn in order to implement mono transformer instances, things like this. Techniques that you might need if you're learning Haskell, if you're working through a book, if you're working on an application, anything like that. Okay. So, applicative. Okay, well, let's see here. Pure is sum a to identity t m of a. Okay. All right, so we have a value of type A. We'll go ahead and bracket that out. Well, what if we just try identity t a? All right, so is this going to work? No. Cannot construct the infinite type a to m of a. Okay, audience, how do we fix this? What do I need to do? Tell me in the chat. Okay, somebody said pure, like that. Oh, no, like that. Yep, So you don't know what type M is, right? You don't know what it is. It's polymorphic, but you do know there's an applicative instance, and you know that if you have an applicative, you have pure, and you just need to embed it in the identity structure of that type. And yeah, that's all you got to do. A really common mistake I see beginners make when they first start doing applicative exercises is they'll do this. And what's funny is it actually type checks. But if you actually try it, so if I do pure 1 and then we'll do just 1, then AT, maybe int. Why is it mad? Oh, I need to, there. Okay, so it got stuck there because it's an infinite loop. As before, you know, it was able to print the show instance of the identity T itself, but as soon as it went to actually force the value, it just got stuck. So if you're looking for a visceral, thrilling demonstration of what a bottom looks like, there you go. It's actually hanging in my GHCI right now. So the type checker in Haskell is very good, but you should actually test things and run them to see if maybe you didn't make a mistake. Okay, so we've got that one figured out, and you can see why this has to be an applicative and not a functor, because if you only have a functor, you don't have pure. Fair enough. All right, let's do this one now. We've got f apply a. All right, well, let's grab the type of apply here, and I've got let me just get that. Okie dokie. All right, so that's good. All right, so F is identity TM, A to B, A is identity TM of A. Okay, well, they're both identity T. So the first thing we can do is just start unpacking them, right? So I'm going to say F prime equals run identity T F. Ooh, don't complete that for me. That was weird. Okay, run identity T A, and yeah, I'm gonna have words with my Emacs config. Okay, there we go. So undefined, that's all fine. What is it though? Well, it's probably M of A to B and M of A, right? So we're gonna lie to the compiler and let it tell us what's up. Okay, so it's M A to B and M of A here. Okay. So how do we apply an M of A to B to an M of A? Attendees, what do you think we ought to do here? What would we put in between here? TIE fighter. Just reusing the applicative. And then it complains that M is not equal to identity T, so just do that. And whoops. There we go. Forgot the C. There we go. Okay. So one of the patterns you're going to see with identity and identity T is that they don't really yield these instances in their own right. They're wrappers for other types that provide those instances. you're basically just unwrapping the identity type, and then you're reusing whatever functor, applicative, or monad that the underlying type gives you. And you can kind of see that from the type signatures, you know, functor, applicative, monad, M. This constraint means you only have a monad for identity T, M, when M itself is a monad. And identity just doesn't really have any structure to it, right? It just contains a thing. So there's nothing about that structure that yields a functor, an applicative, or a monad in its own right. Okay, so any questions? Looks like no. Okay, let me know. Okay, so return just equals pure, simple enough. We're going to do the same thing here. We do f prime, run identity f, m prime, run identity m, and in undefined. And similarly, I'm going to, let's see here. Oh yeah, there's no, aha, yes. See, just caught a mistake. Okay, so it's just a function that generates identity 2 structure because it's a monadic function. Okay, so we don't need to unpack that one because it's not applicative. Okay, so we're gonna say B equals f of m prime. And see what's wrong here. So it says A, M of A. Okay, so the issue is that, we'll comment this out. The type of M prime is actually M of A, right? And if you're not in the mood to set up scope type variables, one thing I will do is I will set up the contradiction, have it tell me what the type is. I'll put the type description in the code and then just comment it out. And that's when I'm just kind of trying to move fast and I don't really want to bother to set up scope type variables. You can do what you want. So, okay, so M of A. Well, F accepts an A, not an M of A, right? So perhaps it will work if we F map. And so it did. So B is unit. It's not, but we're going to say it is. Okay. So what we have here is M, identity T, MB. All right. So this is maybe a little bit intimidating, right? Because we don't feel like we're super close to what we want our final result to be here, which is identity M of B, right? That's our goal type. Again, harkening back to the idea of a proof assistant, you have like a goal that you're working towards in the proof. This is our goal type. This is the final result we're trying to return. Whew. Okay, so what can we do? Okay, well, let's go ahead and set up the scope type variables. And M, and then AT M of A. Okay. So if I uncomment that, it works fine. If I uncomment that, it works fine. We're going to rename this one to MMB. And we're going to see what we can do with this. Okay, so what if I do, oh, let's see here. Well, we can fmap over the M and maybe get rid of the identity T, because we can just run identity T to discharge it, right? So we'll just call it X for the moment, and we'll say fmap run identity t mmb x unit reload m of m of b. That type checks. Okay, real close now, right? X prime m of b. We're gonna call our shot, right? If any of you ever played like billiards or pool with somebody who's really serious, they want you to call your shot before you hit the cue ball, all right? So join X, okay, that worked. And then identity T, X prime, and we're done. That is the identity T monad. And again, the next step, if this is actual code you want to keep, would be to comment this out and then clean it up and rewrite it. Any questions so far? Okay. So, is the way I'm breaking things down kind of a step-by-step, you know, nailing things down with types, using scope type variables, contributing the type checker? Does that whole idea make sense? And let's see here. Okay, let me look at my exercises here. Okay, so from here we just have more transformers. We've got 30 minutes more or less left. Let me go ahead and open it up to general questions people might have about Haskell, and yeah, we can do a little bit more of this if you want, or if somebody has a question about something or wants to see something. Otherwise, we can just talk about whatever you want to talk about. Ulrich asked if it could be done automatically. Well, that's actually a great question. So this can be done automatically, but not really in Haskell. So what you're probably thinking of is something like a language like Coq, which has tactics. And basically, Coq is a dependently typed programming language and proof assistant. And one of the ways that putting together proofs is made less laborious, actually, Paula has the best book for this. Here we go. Hold on. So this guy has a book, couple books, I believe, for learning Coq, and his yen in that book compared to some of the other Coq resources is he uses proof automation and tactics a lot. And so essentially the answer to your question is yes, you can automate like generating a proof or something. It's not really a thing in Haskell for a couple reasons. One is that proof automation and tactics isn't really a thing in Haskell. Haskell's actually like a working language in terms of its design intent rather than a proof assistant. It's more that we're not really trying to turn into a proof assistant, but also the tools don't exist for it. It also doesn't really make a lot of sense. Like often you actually want to specifically state that a particular implementation for something. A proof assistant or tactics or things like that would help more in more highly polymorphic code like this, where there's only really one right way to do it. And the more polymorphism you have, the more likely it is that as soon as you have something that type checks, it's fine. It works correctly, right? But think about the domain and codomain of a function with the type string to int, right? Well, okay, what's the cardinality of that type? Well, it's b to the power of a, so int to the power of string. Well, let's see here, max bound, int, min bound, int, so that plus that plus 1, basically. So that to the power, to the 64 if you're on a 64-bit machine, not guaranteed in Haskell. And then it's to the power of whatever the cardinality of string is, right? Well, what's the cardinality of string? Unlimited. So you probably have a very domain-specific implementation in mind for a type like that, right? A proof assistant isn't really going to be able to guess it, and often proof assistants are designed to run as efficiently as possible, which means they will take as many shortcuts as possible, which is not always what you're looking for. So it's a great question, but if you want proof automation or things like that, you're probably intending to use something more like a Coq, or, as the case may be, Idris 2, right? Coming up later this month. So yeah, it's just a question of fittingness and design intent, and there just isn't really support for it. Now there are like little utilities that will generate. This is the book. Here you go. I'll link it in chat. Yeah, this gets into like tactics and things like that a bit. So yeah, it's just not something you'll really do in Haskell very often. But there are utilities that can generate like expressions given to type and that kind of thing, but they're relatively primitive. I think it's fair to say.
So for the sake of having a little bit more dialogue, first of all, Ulrich, do you want to unmute to ask any follow-up questions or continue that conversation?
I'm fine with that. That was quite exhaustive. Thanks.
Yeah, no problem.
But yeah, maybe one thing, because this was, yes. I mean, all this type juggling to me always seems like a little bit like puzzle solving stuff, and the real thing always, even you stated in your book, is that you have to satisfy the laws. I mean, we haven't talked about monad laws here at all, or functor laws or applicative laws. And you said, like in passing, there's only one solution, so it will basically satisfy them, right? Would be precise, we would also need to prove that the laws hold.
Right. So in highly polymorphic cases where there isn't much structure, so let me add that qualification, right? So if you have something like identity, I don't think it's actually possible to have something that type checks and isn't obviously ridiculous, like you're using bottom or something, that wouldn't also satisfy the laws. Now, that becomes less and less true the trickier the structure of the data type is. And the trickier the structure of the data type is, the less polymorphic it is in the sense that the cardinality or structure or interestingness of the data type inheres in the polymorphic type arguments versus the thing itself. So I would say the types that people get the laws wrong on the most are, I would say state is a huge one. A lot of people get state wrong the first time they implement it. People usually do fine on the maybe, functor, applicative, and monad, but they often get the monoid wrong in terms of the laws, and that has to do with the way monoid is. And in fact, the structure of the monoid type class gives you less help for getting things right. And there's often more than one way to implement it. The same reason you can have two different list applicatives, right, is the same reason you can have multiple monoids for a given type. Functors are unique to a given data type. So it's really hard to write a functor that violates the laws. It's technically possible, but you have to like go out of your way to do something nefarious. With stuff that has a monoidal structure in it, like monoids and applicatives, it's easier to get it wrong. Monads are pretty easy to get wrong, especially with things like state, but that's also because it's just a vertical monoid instead of a horizontal one. So, but there's only one valid monad, like functor, unlike applicative and monoid. So yeah, the trickier the data type is, the more you're going to want to deal with the laws. The reason I didn't talk about the laws is I'm not really trying to tell you how to do these exercises in the complete sense of you need to have quick check or a quick check equivalent, and have props that enforce your laws and check all that stuff. I'm not trying to tell you about that. I'm trying to tell you how to lie to the type checker and just kind of share like a couple of specific tactics that can help you to get stuck less often with the type checker, right? So that you don't feel like you're trying to boil an ocean all at once when you're dealing with a fragment of code that you kind of need to break down into a step-by-step process. Because for better or worse, a lot of people don't know how to break things down into a step-by-step process unless they're actually in like, an imperative like do block or in an imperative programming language or something, right? Because it makes like the incremental breaking down of the problem a little more obvious, right? Because you can just literally like do like one thing and then the other and then the other. Well, you can do that in Haskell too, even if you're not, in the IO monad or in a do block. You just need to know how to do it, and that's what I'm trying to share. So yes, you need to make certain you satisfy the laws and you need to validate those. Please do that. The book makes you do that, or at least tries to. Does that address the question?
Yes, thanks a lot.
Yeah, no problem. Thank you for asking the question.
So Edward has two completely unrelated questions. I don't know which one he's more interested in asking. One of them is about category theory and whether or not it's important to understand for being competent in Haskell. I think I'm qualified to say no, but I did a talk on this topic once, and maybe I should revive it for this meetup at some point in the future if anyone is actually interested in a very basic understanding of category theory for people who know absolutely nothing about it. But I will allow Edward to unmute and ask his question anyway and find out what Chris thinks about this or his other question.
Okay, yeah. So the two questions are kind of related simply just because of Milewski spoke on category theory. He mentions that in Haskell, there's one of the extension languages for deriving functor. Mm-hmm. And there's some things like that. So at least for trivial types, where I think he was saying for trivial types, there are ways where like you can try to get at least functor to be inferred. That was just related to Ulrich's question.
Not just trivial types. If the final type argument of the type constructor is covariant in how it's used, you should always be able to derive functor for it. I don't know if you really want me to go into variance, but basically you can think of covariant as being provided, whereas contravariant would be like needed. The only way to have a contravariant type variable in Haskell is for it to be in the argument, the negative position of a function type. Wow, that is really ugly. Oh man, okay. So just, A to B, the function type, right? So B is in the covariant position and A is contravariant because it's in the negative position. This gets more complicated as you deal with higher ranked types because they actually invert in variance. But setting that aside, if you have some type whose final type argument is covariant, you should always be able to derive a functor for it. There may be some weird technical exception to that, maybe with an existential or something, but if it's existential, it's not going to show up in the type constructor. So I don't really know. I can't think of an example where that wouldn't work. A good way to make certain you actually understand functor really well is to implement it generically in terms of GHC generics. Because what you're essentially going to be writing is you're going to be pattern matching on every possible case in the representation of a data type in terms of GHC generics and implementing the functor generically across all possible like data type representations. And that already exists. So there's a derived functor language extension, right? And then there's also a way to derive functor using GHC generics, but don't look at the existing implementation, just try writing it yourself. This is not a trivial exercise, by the way, but if you want to understand it really well, it's a good way to do it. And then for category theory, you don't need it. And it's not going to help that much. Here's the tricky part. There is helpful folklore that can provide useful intuitions. for how these things relate to each other and how they work. Here's the problem. There is a big, big, big lacuna between category theory and what these things mean and how they work and what you care about and how everything kind of works in that environment versus how they work in Haskell. Functor in Haskell is only related to a functor in category theory through a mirror darkly. It would probably be closer to a natural transformation, to be honest. But being aware of those things is fine, but you're going to spend more time learning a bunch of things you actually don't need for Haskell in the process of learning category theory than you would just kind of picking up some concepts and idioms and intuitions. So like, for example, the idea of applicative being a monoidal functor. We put that in the book. We talk about applicative in terms of being a monoidal functor because we think it's enough seasoning, enough salt, you know, sprinkled on top to help you give you an idea of what it is and how it relates to functor and monoid. And we think it actually tells you something about how it works and what the types mean, right? Because essentially what you're doing with an applicative functor is you're lifting the A to B over the structure, but you also have to monoidally combine the two F structures. You have to stripe them together somehow. And the fact that it's a monoidal combination of structure as opposed to just concrete values doesn't change the fact that it's still monoidal in character, but you know, you're kind of one level up, so it's a little bit hard to kind of wrap your head around if you don't spend some time marinating in it, right? The problem is like, I don't know how useful it would be to learn about strong lax monoidal functors in category theory to get that intuition. I think it's easier to just stare at the types and already know what a functor and a monoid are. The terms get used differently. It's just not, Harold brought up earlier, like he was surprised and initially disagreed with me putting lambda calculus at the beginning of the book, right? If you think that's a roadblock, telling people they have to learn category theory to use Haskell, way more of an issue, way more time and work. Does that answer your question?
Yeah, I think so. Because I've been trying to, like, I've been going through Maluski's book just so I could, like, kind of understand it separate from Haskell. And I was wondering how much they, like, go together or are necessary. So, okay, thank you.
Yeah, I would say it's probably the other way around. Understanding Haskell might actually give you a fighting chance to understand category theory. At the risk of being controversial, I would say from the perspective of category theory, Haskell is actually rather boring. You can implement some categorical structures if you want to, as like for fun in Haskell, but regular sort of workaday Haskell code is not like categorically all that sophisticated. Category theory is interested in like a kind of bestiary of categories, different kinds of categories, many of which would not exist in Haskell in practice. But you could learn category theory because you're interested in learning category theory, and it might be a kind of useful intellectual tool because it is extremely abstract and it could potentially reveal to you how a problem in one area is somehow similar to a problem in another area. And it has its own sorts of rewards for those who can put up with it. That's kind of my take on it.
Yeah, its original purpose is kind of generalizing over and abstracting over and talking about the similarities and differences between structures and different domains of mathematics. And it could be helpful in the context of, and this happens in Haskell. This is where like people like Edward Kmet get their ideas. You know, if you know that there's like, you know, if you take this and you do this with the strong lax monoidal thingy and you can get this, and you already figured out what that looks like in algebraic topology, but you haven't figured out what that looks like in some other domain of math. Well, what if we followed through on that idea in that other domain and saw where it took us, that kind of idea. That's, yeah, I mean, for one thing, you're going to have to kind of be in graduate level mathematics competency to really be able to apply category theory, not to learn it, but to apply it. That's kind of where you need to be at. If you're not in the business of drumming up new abstractions and ideas like Edward Kmet is, then it's probably not helpful, and most of those abstractions aren't useful in practice because they're just overly complicated for the problem they're trying to solve. And it's not that there aren't like useful things in the work he's done. I'm not trying to impugn his oeuvre here, but it's just kind of math for math's sake kind of deal. And if that appeals to you, by all means, do it. It's free. Well, not quite free. The red book costs money. But apart from the cost of books, it's free entertainment, right? But if you just want to learn Haskell, just learn Haskell. It's so much faster and easier than like picking up an interest in advanced mathematics.
Okay, thank you.
So Andrew has a question, and he does not want to unmute to read it. So do you mind reading it and answering it yourself?
Yeah, that's fine. So looks like there's some overlap between what I've demonstrated today and type tolls. Any comment about that? Would you recommend one over the other? Yes, I don't generally use type tolls much, and I would recommend you just do what I did today. Let me explain why. Type tolls are neat, they are fun, but they are less general and useful than the strategies I used today. And the reason I didn't demonstrate type tolls is that I am allergic to recommending things that I don't actually use or have experience with. That's a huge problem in talks in the software industry, especially in functional programming, actually. I don't actually demonstrate or recommend something unless I've actually used it and found it helpful in a reasonable, realistic context. I check in on type tolls because an old buddy and one-time colleague of mine loved them. And every time he would bring them up, every time there's a new GHC release, I would test type tolls on essentially a sampling of situations in which I might want type tolls and see if they were any more useful or had better type errors or anything else. And they never really got better. Among other things, they allied some of the context if you have like type class constraints and things like that. If you find them helpful, if you prefer them, that is fine. Do what you want. But I'm not going to demonstrate something I don't actually use or find helpful. So that's why they didn't come up today.
Correct me if I'm wrong. It's a bit more typical to use them in PureScript, right?
Yeah, I think they also work better in PureScript anyway, though. I could be wrong, but that was my impression.
Yeah. Okay. David, friend of the meetup, has a question. I think David will be happy to unmute and ask his question himself.
Sure. Yeah. Hi, Chris. My
Hello.
question is more general. So somebody that I know has a job as a junior developer after attending a bootcamp. So they're working in JavaScript on a React application. They're aware of the fact that they don't really understand programming, learn programming. I'm wondering, is there a particular language that you would recommend just to learn programming in general?
And they already do React for a living?
Yeah, so I mean, the practical application would be understanding, say, the JavaScript evaluation model. But if there's a better language, maybe Scheme or even Haskell, I'm just wondering what you would recommend.
I would recommend they get better at JavaScript first, rather than splitting themselves across other evaluation models and things like that. The problem is I don't know what JavaScript books have the equivalent of a lambda calculus chapter, but that's the kind of thing they need. The problem is, being functional programmers, we think we can fix everything by rubbing lambda calculus on it, but I just don't think the most efficient possible use of their time is having them learn a completely different programming language. I think they really need to spend time like learning JavaScript. It's just that most JavaScript resources they kind of start with like, well, copy and paste this and see how it goes kind of thing. And that's fine for at least like catching people's interest so they don't give up immediately, but they really do need to go through the evaluation model, which I think you've identified, right? Does anybody in the call know of a JavaScript book that has like a good, like, here's how this actually evaluates or here's how this actually works kind of thing? To be honest, I've never tried to teach somebody JavaScript. I know it, I use it, I deal with mostly TypeScript actually in my day-to-day work, but I've been programming since I was a kid, and I'm not that young, so I don't even remember learning JavaScript, to be honest.
I'm no help here because I learned it the wrong way, copying and pasting and not understanding what the code was doing.
Yeah.
Actually just you know, bit by bit figured it out. But
Yeah.
I don't
You know
think
what?
it's necessarily the way to teach it to somebody else.
How about this? I will research it, and my Twitter is actually private right now, but when I find a book that I think might address this need, I'll tweet about it and also let Steven know about it. He can broadcast it on the meetup group or something like that. So that's
Very
all
kind
right.
of you.
Okay. Yeah. Well, it's an interesting question for me because like this isn't the first time I've heard about a boot camp grad not really knowing how to code or not really being able to kind of mentally model like the evaluation rules and steps and things like that. Like I've run into it before. I just never like sat down and asked myself like, okay, but what JavaScript book would I recommend? Right. So yeah, and I'll check my shelf too, because I have a small library out in the loft out there. I might have something, but I don't think so. We'll see. And yeah, I'll try to find something and see if I can find something that will address that.
Thank you, and thanks for the talk.
Thank you.
Yeah, it's a really interesting question. My previous day job was React. I think there's a lot of material that just sort of teaches React without teaching JavaScript fundamentals. I don't know if it's because you're expected to know them or it seems more practical to just dive into building things and learn by doing. As far as understanding the evaluation model of JavaScript, it's interesting. I don't know if there are recent books organized around that principle. I imagine earlier ones may have been, but the spec changes and I don't know. I always read the MDN documentation personally to learn these things. I wonder if it's, yeah, I know about this series. You don't know JavaScript. Could be useful. I don't know if it's worth recommending to a junior that they read MDN documentation. I mean, I find it pretty accessible. I don't know. Poke around and gradually find your way there. Gary Bernhardt is doing a series of interactive tutorials called Execute Program right now. So this is a way of kind of working with a REPL and learning that way interactively. I think you may have to pay for them, but that's one possibility as well. I might recommend. Ulrich has another question. Ulrich always has questions. He's one of my favorite meetup participants for that reason. So I'm going to let Ulrich go ahead and ask his question.
Yeah, I'm probably always asking these questions because somehow I have a high level understanding, but as a beginner, I still don't manage to actually write sensible programs.
No worries.
It's kind of my second or third attempt. Yeah, a concrete question I have is, on high level, we say Haskell has this super strong type system. You should encode everything into the types because the type checker can help you to get things right. But on a very concrete level, I always struggle how that actually seems not to be used. For a concrete example, I have some username for some authentication server, and yes, I use text, but I don't want to use text actually because I know that certain characters are not allowed. So actually, I want to have a type that is locked down that only allows a couple of them, and only allows like a certain length between 5 and 20 characters for my password or something like that. And I don't find that to be used very often, and I find it kind of difficult to actually how to do it. So there seems to be some libraries, but it's hard to use.
Well, yeah, there's
refinement types, or I do smart constructors, and then I'm trying to do a real abstract data type, like hiding the data constructor, but then I have to use type pattern synonyms to somehow get type matching back, or so it doesn't feel right for something that is supposed to be the core of the language to not allow illegal states, so to say. Now this saying about making illegal states unavailable or
unrepresentable. Yeah. So yeah, I mean, I don't know. It sounds like you're kind of swimming uphill a little bit, maybe. So you're not really going to find like a ton of libraries that like pre-implement something for you. I mean, I just sketched out like your username example as we were talking, right? And that's usually what smart constructors with. I don't really do abstract data types. I don't hide constructors. I operate on the "we are all consenting adults here" kind of principle for that on commercial projects. If somebody does something unsafe with the data type, we will catch it in code review. I also don't really believe in abstract data types in libraries because it just inconveniences my users if they do actually know better and need to do something. This has caused problems, for example, in the text library for downstream users of text before. So yeah, I don't really hide constructors. That's just not something I do. Or at minimum, or at most, I should say, I might have the data type constructors exported from a .internal module, and then they're not exported by default in the main top level module as a way of marking the fact that these are internals, they're not supposed to be touching or messing with. But if you import an internal module, you have no guarantees of stability. You might blow your foot off. That's your foot, not mine. Too bad, right? So from there, in terms of lifting everything up in the type level, don't do that. Don't do that. Try to think of it in terms of 80-20 and incremental safety, right? So I will do something that's easy and reasonably type safe and quick to start with, calibrated on my understanding of the needs of the project with respect to safety and correctness and things like that, because different projects have different needs in that respect, different levels of quality assurance, right? And then from there, if I notice a particular thing being problematic on a regular basis, if we keep getting bug reports about invalid usernames or something, just to take your example and run with it, then I might lock it down more. But specifically for the username example, this is basically the terminal safety for this. This is it. This is the most I would really ever do for that. You're validating string inputs. There's only so much type level safety you can add to that. So just validate it. Just, you don't have strings or text. You just have a username type that abstracts over the underlying text representation, and you have an error type that enumerates the different reasons something could be wrong, and then yeah, that's basically it. And then you use the smart constructor to construct it. So yeah, I would use phantom types, GDTs, things like that here and there, data kinds in some cases in concert with phantom types, but in general, a lot of the Haskell projects I've seen founder and fail and get stuck were because people engaged in excessive fanciness, which segues nicely into the next question about polysemy. Pedro asked a question about how to manage effects. Polysemy is the new boy in the class. Fused effects exist. MTL style exists. Yeah, don't do that, and don't use those. Not if you actually want to use the project in production anyway. I mean, if you want to just play with them for the sake of playing with them, I'm not going to tell you not to be curious, right? But you shouldn't actually use any of that stuff. Keep your application simple. Use the simplest monadic structure you can for your problem. There's basically 2 monads in all of my applications. One's called app, which is the full app context, and then there's one called DB, and that's the database transaction monad. 2 concrete monad types, that's about it. There might be 1 or 2 more after that, but that's about it. And the problem is everybody's trying to slice and dice their monad stacks into a bunch of different trying to do a row type kind of pure script type thing. I would note, by the way, pure script backed off from row typed effect typing. They basically have the equivalent of IO now, right? So an entire programming language community moved away from that model, and we're not learning from that for some reason. There are some cases where using MTL is appropriate, but it's usually more of a library thing than an application thing. An application usually only has 2 or 3 actual monads that the code runs in, if that makes sense. So just define them. Just define a concrete monad. That's all. Yeah, I don't know. I've had to rescue projects by simplifying it and backing out fanciness before. I had one client where their Haskell project was about 50, 60,000 lines of code, and it took 5 to 6 hours to compile just because of the effect system they were using in the application. So please don't do that. Just have a couple simple concrete monad types. Just keep it simple. Just do whatever the Yesod scaffold does. What it does is fine. Even if you're not using Yesod, just use it as inspiration. Okay. It is now 2:02 for me. It is later than that for you. Any other questions?
Oh, Boris has a very interesting question. Should we avoid, in general, should we avoid type level programming?
For now, yes, because it's a lot more hassle than it's worth. Servant's probably the most well-known kind of thing in that space. It's not worth it. One thing I've actually done in the past is I had an application implemented in Yesod, and when I needed some servant-driven code gen, I just wrote out the API type and then generated the code from the API type, but I didn't actually re-implement the application in the servant. Best of both worlds.
So you're saying that for like production code, would you say there are use cases for library code for type level programming?
Not that I'm aware of. I mean, because you don't, I reuse servant not because its design was the best possible way to get that done, but because what exists in the ecosystem that's already ready-made to do the code gen that I needed existed for servant, but there's less difficult, crazy ways of going about that.
So do
code
people
gen is good.
Do people do type level programming simply to exercise some research interest then?
No, I think there's plenty of like practically minded people around servant. We just don't agree on whether the juice is worth the squeeze. I mean, I can just give you an example. One time I was implementing a production app in servant. I needed to make some auth middleware, and the way it was going to work was fairly straightforward. If you were authenticated, I added the header. And if you weren't authenticated, I didn't add the header. Well, that was actually impossible in terms of the way the types in servant worked. And they had to add like a maybe kind of thing for maybe adding a header within a servant handler to the framework. That's crazy. Like use servant if you're a servant dev and you can like fix your own problems and figure it out. But if I was trying to introduce Haskell to my company, I would not foist that on them.
Okay, so if there are no more questions, I think we've taken up a fair chunk of your time, and yeah, it is getting late here in Berlin. And I want to thank you again, Chris, for spending these few hours with us, talking about well, a lot of things: how you work, how to trick the compiler to your advantage, and I always learn from you. I assume everybody in the talk has learned from you. At the same time, I think everyone in the talk should appreciate that they now have, if they want a relationship with Chris, and he was mentioning before, you can contact him. And I don't know if it's a warning or a threat. If you contact him, he will write back. He will engage with you. He will help you. You will have started something. So feel free to do it, if I may say that on Chris's behalf. This is more or less how I ended up friends with him. I just kept bugging him, and he always responded to my questions and concerns with grace and far more information than I required, which was always appreciated. Chris, I hope you'll join us again sometime in the future.
Yeah, I'd love to. And thank you so much for having me. And I hope it was useful. I don't know exactly how advanced everybody in the group was, and I don't know how much of this may or may not have been new information, but I hope at least somebody picked up a trick along the way.
So I'm going to stop the recording now, and then maybe we can spend a few minutes if anybody wants to unmute and turn their video on and say hello and have a quick chat. I know you probably have to go shortly, but just so we have a chance to have a little bit of socializing.
Mm-hmm.
And can you stop sharing your screen? Okay, cool. All right, so happy Bastille Day, everyone. Thanks for joining.